Okay, so this is the review for the test on factoring and solving with a retest on polynomial operations. So, number one, you're adding the two together, which means nothing really changes. You just have to write the terms the way that they are and add. You're only going to add like terms. So you have to be careful that you combine the correct like terms. So I'm going to start out with the highest exponent because you want to put these in order. So 2x to the fourth, and there isn't another x to the fourth, so this is going to stay the way that it is. Then I'm going to move to the x to the third because that's next in line. There's only one x to the third, so I'm going to put x to the third. Then I'm going to move to the squareds. We have negative 3 and positive 2. Negative 3 and positive 2 is negative 1x squared. Then I'll move on to the x's. We've got 5x and 6x making 11x. And lastly, I'll move on to the constants. And those are a negative 1 and a negative 15, which would give me a negative 16. Okay? For subtraction, subtraction is a bit different because you actually have to change all the signs on the second parentheses. So you're distributing that negative sign, which means every sign in the second set of parentheses is going to reverse. It's going to change. So you're going to have the opposite. So notice that all of those became the opposite. And then you're going to continue on like you did above. Start with the highest exponent. We have negative 3 and positive 2, which makes negative x to the fifth. Then we have the x to the fourths. We've got negative 1x to the fourth and negative 1x to the fourth. That makes negative 2x to the fourth. Then we have the x to the third, which is all by itself. So that's going to be 2x to the third. Then we have the x squared, which is also by itself, so minus 3x squared. Then we have the x term, which is by itself, so negative 6x. And then we have the constant, which is also by itself. So each of these were loners. Okay? All right, number 3, we're going to multiply that out, which means we can either do the box or you can do distributive property. That's entirely up to you how you want to do that. I'm going to go ahead and do the box because the majority of my kids like the box. So if I multiply 2x squared times x, I get 2x to the third. X times negative 3x is negative 3x squared. X times 1 is x. 2 times 2x squared is 4x squared. 2 times negative 3 is negative 6x. 2 times 1 is 2. When we add everything together that is alike, we have like terms there, and we have like terms here. So when I add that all together, I'm going to get 2x to the third plus x squared minus 5x plus 2. And that would be your final answer. On number 4, we're going to take the first two and multiply them together. You're going to do the box out to the side. That'll give you x squared plus 2x minus 15. And then we have to take that and multiply by x minus 1. So we have to do basically what we did on the other one. So this time I'll use distributive property. So x times x squared is x cubed. We're distributing this, and then we're distributing this. So we have to distribute 6 times. Okay? So x times x squared is x cubed. X times 2x is 2x squared. X times negative 15 is negative 15x. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times negative 15 is positive 15. So when we add up all our like terms, we end up getting x to the third plus x squared minus 17x plus 15 when we add those all together. Okay? All right, expand using Pascal's triangle. This is a doozy. I'm not going to lie. So we're doing the 6th row, which means we have to use 1, 6, 15, 20, 15, 6, and 1. We're going to start with 2x. Notice how I put this in parentheses. Talk about that in a minute. So we have 2x to the 6th, 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x to the 2nd, 2x to the 1st, and no 2x on the end. Then we're going the other direction, starting with 0. So 0, we have 1 here, 3 to the 1st. Then we have 3 to the 2nd. Then we have 3 to the 3rd. Then we have 3 to the 4th, 3 to the 5th, and the last one would be 3 to the 6th. Now, coming up with these is going to be difficult. You're going to need your calculator because these are big numbers to be multiplying. So, on this first one, this is not 2x to the 6th. We have to do 2x times 2x times 2x times 2x times 2x times 2x. You get the point. So it's actually 2 times 2 times 2 times 2 times 2 times 2, which is actually 64x to the 6th. So don't forget that on all of these, you have to actually multiply that 2 to the 5th power, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, and so forth. Okay? So for this next one, we're actually going to do 2 to the 5th. So this part right here is going to give me 32x to the 5th. Then I have to multiply by 3, then I have to multiply by 6. When I do all of that, we're going to get 576x to the 5th. Okay? Over here, we're going to have 16x to the 4th times 9, that's what 3 squared is, times 15. So that's ending up going to give us 2160x to the 4th if you do that multiplication. Over here, we're going to have 8x to the 3rd times 27, that's what 3 to the 3rd is, times 20, which is actually going to give us 4,320x to the 3rd. For this one, we've got 4x squared times, 3 to the 4th would be 81 times 15, which actually becomes 4,860x squared. Over here we have 2x, so this is 6 times 2x, and then 3 to the 5th is actually 243. And then when you multiply all of that together, you end up getting 2,916x squared. And then when you do 3 to the 6th, you end up getting 729. That is an awful looking problem, but it is the final answer. How fun. All right, so let's divide. So first two, number 6 and 7, can be done synthetically because you have an x to the first term with no coefficient. So there's nothing in front of this x, nothing in front of this x, and you have just a constant with it. So when it's a binomial that looks like that, we can use synthetic division. So we're going to. Remember that it's the opposite outside of the bar, so that was plus 2. We're going to put opposite outside. We're going to put our coefficients up here. We're going to start the problem by bringing this 2 down. Bring that 2 down. It's got to go outside of the bar. Then we multiply on the outside, so 2 times negative 2 is negative 4, and we put that under the next column. Subtract, we get 3, and we start again. 2 times negative 2 times 3 is negative 6. We put that next under the next column, and we subtract or add, so that's 7. Do it again. 7 times negative 2 is negative 14. We add and get 0. Now, we always have to start with 1 degree less than what we started with. So this should be the x squared term, this should be the x term, this should be the constant, and that should be the remainder. So your final answer should be 2x squared plus 3x plus 7, no remainder. For the next one, we're going to start with 5 on the outside. We have 2, 10, negative 7, and 24 up here. We're going to bring this 2 down, multiply, that'll give me 10. When I add, I get 20. When I multiply, I get 100. When I add, I get 93. When I multiply, I get 465. When I add, I get 489. Once I'm done, this is going to be my squared term, my x term, my constant, my remainder. So 2x squared plus 20x plus 93 plus 489 divided by, and you've got to put it over the divisor, which is x minus 5. Okay? All right, this last one is not an x to the first, it's an x squared, so this has to be done by long division. So we're going to set up our problem. There are no placeholders because we have all the terms, which is good. We are looking to make x squared become x to the third. So I would multiply x squared times what to get me x cubed? That's an x. So I'm going to put the x and I'm going to put it over the term with the x's. So this will be x cubed. And then x, you're going to multiply these. So x times x squared is x cubed. X times negative 3 is negative 3x. Notice where I wrote that. I wrote that underneath the x term. So if you write it right next to the x to the third, you're going to add it to the wrong term. So there's actually a placeholder needed right here because there is no x squared term. So make sure that you write that term where it's supposed to be. It's supposed to be with the x's, not with the x squareds. Now when I subtract, that's going to cancel. 3 take away 0 is 3x squared. And negative 4 plus 3, this is going to become positive because negative makes positive. So this becomes negative 1. And we bring down the plus 5. Now we go again. This time we're trying to make 3x squared. So we're trying to make x squared become 3x squared, which means we need a 3. So that's what goes up here. And we multiply, just like we did the first time. So you're going to multiply by the 2 out there. So this will be 3 times x squared is 3x squared. 3 times negative 3 is negative 9. Notice that I put it with the constant. We're going to need a 0x placeholder. So I'm going to subtract these. These will cancel. Negative 1 minus 0 is negative 1x. This becomes a positive 9 plus 5 is a positive 14. So this is my remainder because we're done, right? So I have to write that with my problem. So my answer is x plus 3 plus negative x plus 14 divided by x squared minus 3. That's your divisor. And that would be the final answer. Okay, number 9. In number 9, we have to multiply these two together in order to get what the two terms we do have are equal to. When we multiply that, we end up getting x squared minus 2x minus 15. Now we have to take that, and we have to take the volume and divide it by that. So that becomes my divisor, and the volume is my dividend. The volume goes inside the bar. No placeholders. So we're trying to make x squared become x cubed. So we have to multiply it by an x. When I multiply x times x squared, I get x cubed. X times negative 2x is negative 2x squared. x times negative 15 is negative 15x. When I subtract these, don't forget the signs have to change. This will become positive 2, so that's negative 2x squared. This will become positive 15, so that's plus 4x, and we're going to bring down the plus 30. Now I'm looking to make a negative 2x squared. So x squared times negative 2 gives me negative 2x squared. Negative 2 times negative 2 is positive 4x. And negative 2 times negative 15 is positive 30. Now when I subtract these, notice that all of these cancel. That's a plus 2 and minus 2 cancel. Minus 4 and plus 4 cancel. Minus 30 and plus 30 cancel. So my missing term is x minus 2. All right, number 10. We're going to use synthetic division, and then we're going to use substitution to figure out and check to see that our synthetic worked out. We're trying to find the remainder. This is the remainder theorem that we're wanting to check to see if the remainder theorem does equal what we get when we substitute in a 4 for the x value. So they've already told us that x is 4. We do not do the opposite of 4. We do just 4 because they told us what x was. This was not in parentheses. We do not do the opposite. Our coefficients are 2, negative 3, 5, and 7. We're going to bring that 2 down. Times 4 is 8, minus 3 is 5. Times 4 is 20, plus 5 is 25. Times 4 is 100, plus 7 is 107. So this is our remainder right here. We want to check to see that when I substitute a 4 into our equation, or our function, that I get a 107 when I do the math. So if I put this in my calculator or do the math by hand, we actually do get a 107. So if you'll notice, they check out. So on that problem, 107 would be the answer, what's boxed. All right, part 2 for factoring and solving. So we're going to write down all of our formulas and our perfect squares and cubes, and we're going to kind of set us up for the factoring that's on the back. Okay? So the difference of squares, that's going to be a squared minus b squared, and that's equal to a plus b times a minus b. For the sum of cubes, we're going to cube and add because we're doing sum. That's going to be equal to a plus b times a squared minus ab plus b squared. The difference is almost identical, with just a subtraction sign in the first one and an addition sign as the second one. The last sign in that is the same. Okay, our 10 perfect squares. That's just 1 through 12, or 1 through 10, squared. So we have 1, 4, 9, 16, 25, 36, 49, 81, oops, sorry, 64, forgot 8. 64, 81, 100, 121, 144. I had my kids do 12 instead of 10. The perfect cubes, 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000. All right, let's factor. Just one moment. Okay, sorry about that. Technical difficulties. Okay, so we're going to talk about, I want you to write down what you used for round 1, the type of factoring that you used, and then factor it. So in the first one, there was no greatest common factor, so we used dots to be able to factor that. We took x to square, and we took 12 to square, so our answer is x plus 12 times x minus 12. That's what difference of two squares does. In number 2, there was no greatest common factor, so again we use dots because both of those are perfect squares. We squared 6x to get 36. We squared 7 to get 49. So 6x plus 7 and 6x minus 7 would be our two factors. Number 3, no GCF, but this is a sum of cubes. If you look at your perfect cubes, sum of cubes. So we cubed x and we cubed 5. So those are the two numbers we're using. We're going to add them together, x plus 5. Then we're going to take x and square it, subtract. We're going to multiply the two together, 5 times x. Then add, and we're going to square 5, which is 25. And that would be the final. For this one, no GCF. So again, we're using cubes, but this is the difference of cubes. So we cubed x, and we cubed 4. So we are going to subtract them, because this is subtraction. Then we're going to square the first one. We're going to add the 2 multiplied by each other, which is 4x. And then we're going to add the last one squared, which is 16. Okay, for number 5, our first round is going to be grouping. Should have used grouping on that one. We're going to group the first 2 and take out the greatest common factor, which is x squared, leaving us with x minus 6. Then we're going to group the second 2. GCF is a minus 4, leaving us with x minus 6. We want to take out that negative so that we have a minus 6 in our parentheses. Now, we've got x squared minus 4 as the first parenthesis and x minus 6 as the second parenthesis. So, now our second round is going to be dot. So notice that this x squared minus 4 can still factor into x plus 2 times x minus 2, and then we have the x minus 6. That's okay. So we have those 3 as our factors. Okay, for the next one, we're also going to use grouping. I'm going to erase this real quick so I can see what that is. Okay, so we're going to group the first 2. They have an x cubed in common, leaving with x minus 1. The second 2 have an 8 in common, leaving with x minus 1. Okay, so we're going to get x cubed plus 8 as one parenthesis, and x minus 1 as the second. Now we can notice that these can be factored using the sum of cubes. So if I do the sum of cubes, I'm going to go this way. We're going to have x plus 2 because I had to cube 2. That's how I got the 8. And I had to cube x. That's how I got the x cubed. So x plus 2 times x squared minus 2x, you multiply the 2 together, plus 2 squared, which is 4. And then we still have the x minus 1. So this is going to be our final answer. Number 7, round 1 is a greatest common factor. You cannot group in this one. There's only 3 of them. They've got a 12 and an x in common, leaving us with x squared minus 7x minus 8. The second round is a trinomial. And so we're looking for 2 factors of negative 8 that add up to negative 7. So we're going to keep the 12x from round 1. This is going to factor into the 2 numbers are negative 8 and positive 1. Those are the 2 numbers that give us that. So x minus 8 and x plus 1 are our two factors. Number 8, grouping is going to be our first round because there are 4 terms. So we have 2x squared as the GCF, leaving us with x plus 4. Second set of terms have a 14 in common. 14 goes into 56, and it leaves us with x plus 4 times. So we end up having 2x squared plus 14 times x plus 4. Now, round 2, notice that you would use GCF because that's the only thing you can do. They have a greatest common factor of 2, leaving us with x squared plus 7. And then you still have the x plus 4. So this would be your final answer. Because x squared plus 7 cannot be factored anymore. 7 is not a perfect square, nor is it a perfect cube. All right, in 9 and 10, we have to solve once we get them factored. So in this first one, we're going to use a GCF. They have an x in common, so we'll be left with x squared plus 9x plus 14 equals 0. This can be factored into a trinomial. It can be the trinomial factoring that we do. So we're looking for 2 factors of 14 that add up to 9. So that's going to be 7 and 2. So this, we keep the x from round 1. This is going to be x plus 7 times x plus 2. Okay? Now that would be done if we were to factor, but because there's an equal 0, we have to take each one of those factors and set them equal to 0. So our solutions are going to be 0, -7, and -2. Okay, last one. We're going to use grouping in round 1. So these two have an x squared in common, leaving us with x plus 3. These two have a -4 in common, leaving us with an x plus 3. So we're going to have x squared minus 4 times x plus 3 equals 0. So now round 2 is going to be this right here, the x squared minus 4. That's dots, difference of 2 squares. So this becomes x plus 2 times x minus 2, and then we have the x plus 3. So we have to set each one of those equal to 0. And so our 3 solutions are -2, +2, and -3. And we're done.